Hello and welcome to lesson 6.2. Today what we're going to talk about is we're going to talk about the number of solutions in a system of equations and how you can kind of anticipate if there is a solution or how many solutions there would be when looking at a system of equations. Just a reminder, what is a system of equations? A system of equations is when you have more than one equation being considered at the same time, right? So we know equations, especially our equations, are mainly linear. We can graph them. When we graph them, they typically create straight lines for us, but they could do lots of different things as well. So that would be a system of equations I just drew there, where the blue is one equation, the red is another equation. They both made straight lines. The solution to a system of equations is if and where those things intersect each other. So this would have a solution right on that green spot right there, because that's where those two things intersect. So that is the solution. Cool. Let's jump into it. So we're going to read this little narrative here. It says, as part of a high school work experience course, 3 students have been placed in 3 different burger restaurants. Deja has been placed at Burger Shack, Shelly has been placed at Big's Burgers, and John has been placed at the Burger Haven. Detailed below are the first 2 orders taken by each student and the total cost calculated by the student for each order. Burger Shack. For Burger Shack, the first order, Deja charges $28 for 4 burgers and 2 salads. For the second order, she charges $34 for 6 burgers and a salad. Big's Burgers. Shelly charges $18 for a burger and 3 salads, and $54 for 3 burgers and 9 salads. The Burger Haven. John charges $32 for 2 burgers and 4 salads, and $42 for 3 burgers and 6 salads. Okay, awesome. We have 3 students that are working at Burger Shack, so they sold some burgers. We're going to turn this into math somehow. Let's start with question 1. It says, let X be the cost of a burger. Okay, X, cost of burger. And Y be the cost of a salad. Y, cost of salad. Write a system of equations for each scenario. So if we look back, we'll start with Burger Shack. 2 things happen, the first order and then the second order. So the first order is $28 for 4 burgers and 2 salads. To represent that mathematically, you would say $28 would equal 4 burgers, so 4x, because x is burgers, the cost of a burger, plus 2 salads, and salads was y. Okay, so that's what you're doing. You're going to take these words and turn them into math. And we can do it with the second order too. In the second order, she charges $34, so the total is going to be $34. And that would get you 6 burgers, so 6x, plus 1 salad, just 1y. If you put a 1 in front, that's fine. This is a system of equations for Burger Shack. Right? 1 gave you the first total, 1 gave you the second order. But you could turn that into equations, which we just did. We're considering them both at the same time, so it's a system of equations. We can do the same thing for the other 2. So if we look at Shelly's Burgers, $18 for a burger and 3 salads, so 18 for 1x plus 3y. 54 for 3 burgers and 9 salads, so 54 equals 3x plus 9y. And we can do that for the third one too. If we go to Burger Haven, we have $32 for 2 burgers and 4 salads, so it'll be 32 equals 2 burgers, 2x plus 4y. And the second equation would be $42 for 3 burgers and 6 salads. So 42 for 3 burgers and 6 salads. Like that. And what we've built is we built a system of equations for each store based on the cost of a burger and the cost of a salad. We're now going to have a couple questions that kind of run us through this. So it says, consider the equation for Burger Shack. Write each equation in terms of y. What that means is, in terms of y, that means y equals. And use a graphing calculator to determine the cost of a burger and the cost of a salad. Okay. Let's just convert those. So if you look at the red one, it's 28 equals 4x plus 2y. You're going to move the 4x over to get 28 minus 4x equals 2. And you're going to divide everything by 2. And you get 14 minus 2x equals y. That's going to be your red equation. Your blue equation, you can try to move it in your own, so it'd be good practice. The way you would move it is you would subtract 6x from both sides. And you get 34 minus 6x equals y. Now, what you could do with both of those equations is you could graph them. When you graph them, you're going to have to set up your window. Right? And your window, when you click it, gives you things like x min, x max, x scale, y min, y max, y scale. And the best way to do this is to honestly consider graphing it by hand. So for instance, if I wanted to graph this situation where I know X is the cost of a burger and Y is the cost of a salad, then I could think of not X min, I could think the minimum cost of a burger. And the minimum cost of a burger would be $0. So that would be your X min right there. Your X max, the most that you could charge for a burger, I don't know, if you're paying $10 for a burger, it'd be a pretty good burger, I suppose. So that would be your X maximum. And when you put that in your calculator, what you're doing is you're creating this graph like I just did, like the 0 and the 10 that I put on that x-axis. The scale is what you're going up by. I just like to always count by ones. It just makes my life easier. Y minimum. If you think of y as the cost of a salad, what you're really saying is what's the minimum cost of a salad? Well, the least you could charge for a salad would be $0. So your y minimum should be 0. Y maximum, the most that you could pay for a salad, I think probably $10 would be a pretty expensive salad. So you can do that as your price of a salad. Now, it might be more than that, right? So you could always graph it and it won't work, and then you have to do it again, whatever it needs to be, right? But you can change it around to make it so it fits each scenario. Your maximum, $10, your scale is going to be 1 again. And if you graph it and you can't see what you want to see, that's fine. If you can always change your window again, right? So I want you to try to graph both of those equations, the red and the blue, and let's see what kind of lines we get. Okay, when I graph this, my first equation, which is my red equation, looks somewhat like this. And my second equation, if I graph it, looks somewhat like this. Awesome. Now, ideally, you would want to be able to see the x-intercepts and the y-intercepts. I can see the x-intercepts right now, where those two lines cross the x-axis, right? They cross here and here. Oh, sorry. Here and here. But I can't see the y-intercepts. If I follow my line, like it should be up here somewhere. This one's going to be like way up here somewhere. So if you wanted to be able to see your y-intercepts, what you'd have to change is your y maximum because you can't see high enough. We're fine though because we're not actually looking for our intercepts. What we're looking for is our intersection point. Right? This is what we want to find. And as long as we can see that, then we will know what our answer is. And that answer, if you go second trace intersect, your fifth option, right? We learned about this in 6.1. So second trace intersect tells us that these two lines cross each other at 5, 4. And what that's specifically telling us is the cost of a burger and the cost of a salad. Because remember, X is the cost of a burger and y is the cost of a salad. So I know that at this store, the cost of a burger is $5. Cost of a salad is $4. And I know that because that's the only prices that would make those equations both work. And since both of those equations both happened at Burger Shack, then that has to be the price of a burger and the price of a salad at Burger Shack, because it's the only way both orders would make sense. If we try it for part B, it says repeat part B for Big's Burgers. Can you determine the cost of a burger and the cost of a salad? Okay. We're going to turn both of Big's Burgers into equations. So you're going to take 18 equals x plus 3y. You're going to subtract the x and divide the 3. So you get 18 minus x equals 3y. Then you're going to divide the 3 to get 6 minus 1 over 3 x equals y. That's the first equation. If you don't remember how to do that, don't sweat it so much. Let's just keep talking about the systems of equations part. The second equation was 54 equals 3x plus 9y. You're going to move the 3x over to get 54 minus 3x equals 9y. Then divide the 9 to get 6 minus 3 over 9 x equals y. I ran out of space there. I apologize. Like that. Awesome. Now you can graph both of them again, right? I'm going to use my same window that I did before. I'm going to graph both of them. When I graph both of them, I'm going to get two lines. The first line represents the first order. The second line represents the second order, right? That's what these equations actually are telling you. If you do that, you're going to get two graphs that are actually the exact same. So mine just looks like this. If you have a newer calculator, you might be able to see both colors on top of each other. So the lines are actually like that, like right on top of each other. If you have an older calculator like myself, it's just a black line and it looks like I only have one equation. And that's because these equations are the exact same. So if I look at what I graphed this and I graph this. One is 6x minus 1/3. One is 6 minus 3 over 9. 3 over 9 is 1/3. So these are actually the exact same equation. So considering that these are both the exact same equation, would I be able to use this graph to figure out what the cost of a burger and the cost of a salad is? Would I be able to do that? And the answer is actually no. The reason the answer is no is if we look at this graph right here. Oh, I want to zoom in, but it won't let me. Let's see. No, I'm sorry. I want to zoom on the graph, but that's okay. I can't. So if we look at the graph, we have two graphs that are right on top of each other. Our solution is where they cross each other, but they cross each other all the time, right? They cross each other right there. That's an intersection point. They cross each other again right there. That's another intersection point. They cross each other again right there. That's another intersection point. So these are all different possible solutions, right? The first solution might be, oh, a burger is $1, a salad is $4. The second solution might be, oh, it's $2 and $3. The next solution might be burgers $3, a salad's $2. But we have all of these infinite solutions all the way around. So we don't actually know how much a burger and a salad cost because we don't know which intersection is the right intersection for this scenario. We call this infinite solutions because the lines are perfectly on top of each other. They cross over and over and over and over again. All right, let's try the third one. So if you did the third one and you took those equations, I'm just going to write out what they would be so we don't have to spend too much time on it. This one would be 32 divided by 4. And then we'd have negative 2x divided by 4. Okay. I need to move my screen here. We'd have 8 minus 1 over 2x equals y. And if we did the second one would be 7 minus 1/2 x equals y. Awesome. If you went ahead and you graphed both of those things, your graph would look somewhat like this. The red one would start about here, and it would be on a downward slope like that. The blue one would start here, and it would be on the exact same slope like that. So if you got this question and they said, can you figure out how much a burger and a salad cost for this situation? What they're asking you to do is figure out where they intersect. These things have no intersection point. That means there's no solution. There's no price of a burger and price of a salad that would make both of those equations actually happen. Any x value I chose would never give me the same y value for both lines because there is no intersection point. That means there's no solution to this equation. Cool. That means whoever was working at Burger Haven, who was working at Burger Haven? Whoever was working at Burger Haven made a mistake when they were doing their orders, right? Because they obviously charged somebody the wrong amount. Who knows how much that amount was, but they charged the wrong amount. Oh gosh. Okay. Let's see if this works now. I'm struggling. Maybe you've heard my dogs barking during this. I'm moving my page around. I can't zoom in. All kinds of crazy things are happening right now. Okay. So that was kind of like a bit of an exploration and exercise. It might have been kind of confusing, especially since they added word problems into it. So if you're a little lost, that's okay. We're going to take things, we're going to simplify them a little bit, and we're going to just talk about systems of equations again, kind of right from scratch. And we're going to talk about the 3 different scenarios that you can get when it comes to systems of equations. We're going to take all these. I want you to take a moment. We've practiced and we've talked about graphing all of them. I want you to try to graph all of these equations. Okay, so do the first one, draw them, right? Like draw your line. Do the second one, draw your line. Do the third one, draw your line. See if you can get the right answer. Okay, and then I'll graph them all too, and you can see if we're close or not. When you graph them, we're going to use the standard window. So the standard window, if you remember, is your x minimum is -10, your x maximum is +10, your y minimum is -10, your y maximum is +10. Awesome. Hopefully you paused the video. You tried to do it. We'll do the first one here. Should have started at 5 and should have gone upwards like this. So you should have had that as your equation. The second equation right here, you should be at 1 and you should be looking somewhat like that. Yeah, we'll say that. If you look at your second equations over here, this first one should have looked like this. Your second equation right here should have looked something like this. Oh, that's too high. Maybe like that. Awesome. If you graph the third equation, you might have found that you had a bit of a problem. So if you graph that one, you should have had something like this. Maybe not quite that steep. And when you graph the second one, you actually should have had the same thing like that. And they would be right on top of each other, so you wouldn't even notice. It would just look like y equals the exact same thing. Your calculator would have done one graph. Cool. Let's talk about these graphs. So when you look at the first graph, How many solutions do I have in that first graph? Well, a solution is an intersection. That's the intersection. Would these lines ever intersect again? So if I imagine I kept going on one of these lines forever and ever and ever, and if I kept going, would these lines ever meet up again? And the answer is no, right? They would never meet again. You can see all the arrows are going in opposite directions. They're getting further apart from each other. So I can confidently say that this question would have one solution. There's only one intersection point. For the second question, when I look at that and I say, okay, how many solutions does it have? Currently, it looks like it has zero, right? It looks like there's zero solutions there because there's zero intersections. But we have to consider, what if these things kept going forever and ever and ever? Would they eventually cross each other, right? Are they getting closer together or are they getting further apart? And that counts in all directions. So we have to think really hard about this and be like, would they ever cross? If I made my window bigger and bigger and bigger, would they ever cross each other? The answer is no. But you have to be able to prove it mathematically why they would never cross each other. And the way I can prove it mathematically that they're never crossing each other comes from y equals mx plus b. If you look at both of these equations, m is your slope. These things have the same slope. When you have the same slope, that means you have things that are parallel. And parallel lines will never, ever cross each other as long as they're not starting at the same point, right? They're not on top of each other. This means this does have no solutions. It has no solutions because they never cross each other. This third case is interesting. So if I said, do you have a solution there? The answer is yes, right? Because these two lines do intersect each other, but they intersect each other in a million little places and everywhere in between. Right? If you kept going along these lines, they keep crossing each other forever and ever. We call this infinite solutions, meaning that every single x value would give you the same y value for both equations. These are the only three scenarios you should ever get in this unit as long as you have linear lines. Okay, you'll always either get one solution, no solutions, or infinite solutions, as long as you have straight lines. We're going to fill this in a little bit. So our three scenarios is one solution, no solution, and infinite solutions, which we say like this, infinite solutions. An example of each. So I'll give you some examples. In this first one, you could just pick two lines. As long as they cross each other anywhere, we call that one solution. No solution is lines that are parallel. We could have lines like this. These are parallel lines. They would never cross each other. And the third scenario we could have is two lines that are right on top of each other. So for instance, these two lines are right on top of each other. That would give me infinite solutions. To get one solution, mathematically, all you need to have happen is you need to have different slopes. If two equations have different slopes, it's guaranteed they'll cross each other at some point. Now, their slopes might be really close to the same, but if they're different, so if you have one slope is 1 and one slope is 1.1, they will cross each other because one of them is going up faster than the other. So eventually they must cross. To get no solutions, you must have equal slopes. So the slopes are the exact same, but the y-intercepts or the b value must be different. If the b value is the same and the slopes are the same, that means your m is the same and your b is the same. What you have is two lines that are the exact same on top of each other, and you have infinite solutions. Again, these are the only three scenarios that you'll ever run into for linear equations. Again, linear equations are equations that are straight lines. Kind of cool, right? So you should always be getting one answer. Sometimes you'll get no answer to a question, and sometimes you get infinite answers, and that's kind of crazy. So these questions, without graphing, analyze the system and determine whether the system has one solution, no solution, or infinite solutions. The best way to do that is to figure out what the slope and the intercept are for each one. So the best way to do that is to get them into y equals form. So if I look at this first equation, I want to subtract the 3x to the other side. That means I have 5y equals 15 minus 3x. Then I want to divide both sides by 5, so I have 3 minus 3 over 5x. If I compare that red equation with this equation right here, these two equations have same slope. Both have a slope value of negative 3 over 5. Right? Same slope. But they have different y-intercepts, or the b value. This one has a y-intercept of 3. This one has an invisible plus 0. If I have the same slope but different b values, that means I have parallel lines. That means there would be no solution to this question. Awesome. If we look at question 2, the first equation, if you reordered it into y equals mx plus b form, the way I would do that is I would actually add the 4y to both sides. So I had x plus 8 equals 4y. And then I would divide both sides by 4 to get 1 over 4x plus 2. Uh-oh. My screen is freezing. Plus 2. Hey, there we go. Equals y. If I look at my second equation right here, and I determine that they both have a slope of 1 over 4 and a y-intercept of 2, I would realize that this is same m and same b. That's infinite solutions. Those are the exact same lines. That means they cross each other at all times. Right? Same y, same m, same b. That means same lines. That's an infinite solution. If we look at our last example here, to get y by itself, I would subtract 7. So I have 12 minus 7x. If I look at the second equation, I have to do some math. So I'm going to move the x over. So I have negative 6y equals 5 minus x. And then we divide by negative 6. So I have y equals negative 5 over 6. And then positive 1 over 6. It's a negative and a negative. I look at those. Those have different slopes. That means there's going to be one solution. I don't know what that solution is, but I know there should be one solution. And knowing that kind of stuff, like what we just talked about right now, is a good way to quick check to see if you should get an answer. Because sometimes you're going to get questions where they're like, solve this system of equations, and you start getting frustrated because you can't find the answer. You're graphing it, but you can't see the answer. And then you realize, oh, wait a minute, these things are parallel lines. There should be no solution. And then I don't have to panic so much and get myself confused over why there's no answer. You understand that it's possible to have no answer to a question. Wicked. That's all we're going to do today. We just wanted to do our how many intercepts are there, how many are possible. If you want to do a practice question on graphing, feel free to try this and try graphing practice. We did a lot of that a couple of units ago, so I feel that's just kind of up to you if you want to do more practice if you're not so strong at graphing yet. Awesome. Take care. Hope to see you all soon.